In this video, we are going to expand on what we have learned with logarithms and the laws of logarithms. And we're going to see how some of the different ways that it might be able to be applied to different scenarios. So let's say we wanted to write this equation, y equals a squared b. We want to write that using logarithmic equations, just to kind of get us in the practice of that. So what we're going to do is, just like if we want to square something, or square both sides of an equation, or if you want to take the square root of both sides of an equation, you can take the logarithm of both sides of the equation. We're just going to use log base 10 because that's our most common base, and we've got log, so we've got log y and log of a squared b. Now, because we know our laws of logarithms, we can expand this log a squared b. We keep our log y, and our log a squared b, we know that if we're multiplying two numbers inside our logarithm, it's the same as adding them. So we could say log a squared plus log of b. And then we also know one last step here, that if we have log of a squared, that's the same as 2 times log of a plus log of b. So that's how you would write that using logarithms. So we can do another one. We'll see what another one looks like here. Maybe log of p equals, I'm sorry, not log of p. We're just going to say, already telling you where we're going to go with this. P equals 20 over the square root of n. Alright, so I just kind of gave it away. We're going to take the logarithm of these things, just like in the last one. So we're going to have log of p equals log of 20 over the square root of n. Alright, so if we're multiplying two logarithms, or a number inside our logarithms, we add them. If we're dividing two numbers inside of our logarithm, we subtract them. So we've got log of p equals log of 20 minus log of the square root of n. Now, we can take this one step further. We can take it one step further because we know this square root of n. We know we can write that as an exponent. So if we take log of p, what is the exponent of a square root? The exponent of a square root, if you remember, is a fraction. So we're going to take it to the 1/2. So if we have n to the 1/2 power, that means we're going to multiply just like we did with our a and our 2 in our last problem over here. So we're going to take log of p equals log of 20 minus 1/2 log of n. Alright, so there's a couple examples like that. Another thing we might want to do is kind of go backwards from this. So maybe we've got these logarithms with all these different variables, and we want to try and consolidate them. Because if we have all these variables, it might be easier to work with outside of logarithms. So let's see what happens with that. Let's get this cleared out a little bit here and give us as much space as possible. Alright, here we go. So maybe we have log of a equaling log of b plus 2 log of c. Well, now we're just working backwards. So we're working backwards. So we want to get rid of these logarithms. So what we're going to do is we're going to consolidate this side first into one logarithm, and then we're going to take everything to the same base. So we've got log of a, and then let's see, we're adding two logarithms, same bases. Actually, before that even, we need to take care of this 2. So we've got log of b plus log of c squared. So we get that 2 out of there. And now we have our adding our two logarithms, same bases. So we know that we can combine those into a multiplication problem, or a multiplication in our log. So we've got bc squared. So now if we have the same bases, what we do is we're going to take both of these things And we're going to raise it. It's hard to explain exactly what we're doing, but we're basically taking 10 to the power of log A and 10 to the power of log BC squared. So this might even look better if I kind of, oops, maybe if I bring it down there so it looks a little bit more like raising those things both to the same power. So now if we've got the base 10 of log base 10, that cancels out. Base 10 to the log of base 10, which is this little bit right here. So that cancels out, and we're left with, after all of that said and done, A equals BC squared. So it's a similar way that we have looked at that before, kind of going backwards. Let's look at another one that's a little bit harder than that, a little bit trickier. So we've got log of M equals 3 log A. All right, you're saying probably no big deal. I can do all that, not a problem. Then we're going to have minus 1. Ah, okay, so there's the trick. So what do we do with this 1? Well, we have to think about what logarithm will calculate to 1. And we're already talking about log base 10 here. So log base 10 of m, remember if there's not a base there, it's the assumed 10. So we've got our log of m, we have our, let's just take this log of a cubed. We can get that out of the way to begin with, because we know we're trying to get rid of our logs. But before we can do anything with that, that 1, we have to think about what base and what number would we have to raise that to. So if we take log of base 10 of 10, or log of the base anything of that same number, that's always going to equal 1, because we've got it to the first power here. So log base 10 of 10 to the first power is going to be whatever is left in that exponent, because all that stuff will cancel out. So you want to strategically choose the base and the log that you're going to use for that. So in this case, it's all base 10, so we're good with this. So we've got log of m equals, so now we're subtracting these two things, so we need to divide them. Log of a cubed over 10. And now, just like in the last problem, we're going to take both of these things, we're going to raise it up to the, we're going to take 10 to the log m power, 10 to the log a cubed over 10 power. These things cancel out, so we're left with m equaling a cubed over 10. So that's a way that you can kind of simplify that. Let's see, I think there's just one other type of thing that I might like to show you, and that would be using some substitution. Sometimes people get all tripped up when we've got substitution problems, but hopefully it won't be too bad. So let's get ourselves some more space again and see where we can go with this. We'll extend that up a little bit, just in case we need some extra space here. All right, so if we have, let's see, if P equals log of base B of 2 and Q equals log of B of 3 and R equals log of B to the 5. We want to know what, let's try log of 6. Log of 6. Log of B, sorry, log of B of 6. So we want to rewrite that using P's and Q's. All right, well, we know that, let's see, let's look at our properties. We know that if we've got a multiplication, or if we've got a number here, and we could break that into a product, that could be the same thing as log of B times, or of 2 times 3. So all I did was I looked at that 6 and I broke it into a product, into a multiplication problem. All right, so if I got this, now I can see, all right, well, I've got log of B of 3, we've got log of B of 2. So what am I going to do? I'm going to rewrite this again, and this is going to be log of b of 2 plus log of b of 3. And now looking at our variables up above, we want to just substitute this and write this in terms of these variables. This could be the same thing as p plus q. So we've got just our solution there for that one. So that's kind of how you can do some substitution with this. There's various different ways that you might see problems like that, but it's all very similar in form. Kind of taking these numbers like this 6, breaking it into factors or into products that will strategically help you calculate or get you into the same basis as your variables up above. So I hope that helps. Good luck, and we'll talk to you soon.